So, hello everybody. From this lecture onwards, we'll be studying object-oriented programming. So, we have two PPTs for OOPS concept. We will be starting ahead with what basically is OOPS and why do we need it. So, OOPS basically means object-oriented programming. So, why did we need object-oriented programming? So first of all, the coding we did till now just didn't represent our real world at all. But if we switch to object-oriented programming, it basically shows and relates the programming to real world. So as soon as we relate the programming to real world, it's more usable. So first of all, we use OOPS to escape the chaos of linear code. So, as application scale, linear top-down programming inevitably tangles into unmaintainable spaghetti code. So, what does this line mean? So, so what does this line basically mean? So, this line basically means that when we are writing a code, we are just writing in a top-down approach, and everything is just congested and it's tangled like a spaghetti. So, just like this, you can't really get which part of code is doing what. So you just write everything and just tangle everything. So this is called the spaghetti code. And object-oriented programming offers an escape by mapping software to real-world entities. It empowers developers to build modular, maintainable, and scalable application by organizing code into distinct, self-contained units that possess their own specific data and actions. So, just like functions were used to just functions. Why were functions used? Functions were used to suppose if we wanted to, if we didn't want to repeat a code, we just put that code into our function and use it every time. So, what does this oops does is it just separates out everything as, on the basis of their usage. So, this separation is called a class. So this class is called the separation and maintenance of the code, so that it's not all tangled up and we don't have to just tangle it up and use it. So there are two things to be studied in the beginning. That's and the name itself, object-oriented programming, the object and the class. So what is the class? Class is basically the blueprint. Class is blueprint for creating objects. Okay, so suppose you want to create a gear, all right. So to create a gear, you'll have to first map out its length, breadth, and everything, and make a blueprint for it. And then you will fill out that space by a mold or any type of material you want to use. So here you can see the key traits of class. It's a blueprint for creating objects, collection of potential objects, defines a set of attributes and methods. Key traits of objects are it's a specific instance of a class. So suppose this is an object, this is one instance of this class. Suppose this is an object, this is one instance of this class. Suppose this is an object, this is one instance of this class. It's not the entire class, so it's just a part of this class. So it holds its unique data, represents a specific physical implementation. All right. So keywords to remember for class to for defining classes: class, init, and self. Both of these methods will be studying in coming class. And keywords to remember in object is nothing, just the names you will be giving to the objects will be depending upon you, just like the variable names. So drafting the blueprint with class definitions. A class defines the universal traits and initial setup for every object it creates. Attributes are variables that belong to that class, always public and accessed using the dot operator. So this is basic code for class. Suppose you created a class dog, alright? So you defined a function init. Init means initialization. So you are just initializing the class. And there are two parameters. One is self, and self will be always used in init. Self is just used to access uh, variables from different methods. I'll just show in a code. So the name and age. So self dot name is equals to name. So you are creating an instance of a class. So that means you are saying that you have initialized self dot name as the value of name and self dot age as the value of age. So this part is called constructor, the init part. So this refers to the current object. Uh, it refers to the current object being created, enabling it to store its own unique localized data, isolated data. So it's just localizing the data within the class dog. So dog name can be different for different dog. So it's just initializing the names and age. So like next will be the internal autonomy of a instantaneous object. Now, when an object is created, it represents a specific implementation of the class holding its own data. Every object is defined by three concentric layers. First of all, the core, what is the identity, the machinery, the state, and the outer shell, the behavior. So core is just gives the name to the object, giving name to the object is defining its identity. Machinery, its state, represented by its attributes, reflects basic specific properties and stored data of the object. So uh, next is the outer shell, represented by methods, reflects how the code responds to and interacts with the objects. Now, instantiation brings the blueprint to life. Creating an object involves instantiating, sorry, instantiating a class to create a new instance. This allocates memory and distinct identity to the previously theoretical blueprint. Suppose you want to create dog1. So you will say dog1, the object name, then you will type the class name, then you will type the attributes. Alright. So now if you want to access, you will just say dog1.name. That will give output as whatever you have given here, and dot age will give the output whatever you stored here. Right. So this is how you instantiate a class, sorry, an object. You can also make many other dogs, dog2, dog3, dog4, and dog till n. That's your choice. It depends on the data. Now there are four forms of object-oriented programming. These are basic four pillars. You will get these in every language. Every language you will learn except C. It's a procedural programming language. Except C, every single programming language has all these four pillars. First of all is inheritance, polymorphism, encapsulation, and abstraction. We'll study um, deeply about these in coming lecture. So inheritance basically means here that this function is inheriting the properties of this, sorry, this class is inheriting the properties of this class, this class is inheriting the properties of this class, same with this, same with this. So this is just inheritance, just like you this is suppose your grandfather, this is your dad, and this is your uncle, this is you, your brother, these are your cousins or nephew cousins, sorry. So you are inheriting your grandfather, your father is inheriting your grandfather's properties, and you're also inheriting your father's property. In the same way, your uncles inherited your grandfather's properties, and now their sons or daughters will be inheriting them. A polymorphism that means that one function is flexible enough to do separate tasks. All right. Encapsulation means just capsulating the data into one, so it's restricted and protected. Abstraction means just hiding the uh, data that's not useful to the user, and we only show the data that's useful, just like suppose a radio box. Okay, you don't see anything except the radio box controls, and internals are already hidden because that's not are not of your use. It's a part of abstraction. So that's how it's done. Now, inheritance establishes an evolutionary hierarchy. Inheritance allows a child class to acquire properties and methods from the parent class. It supports hierarchical classification and drives massive code reviews by preventing developer from rewriting shared logic. Suppose this is a parent class, and there are some child classes, and they want to inherit the properties of these, so they can easily inherit these properties. Now, suppose this is parent class is animal, and animals will eat and sleep, and child class is dog. Dogs will also sleep, and another child class is cat. They will also sleep. They will also eat. They will also eat. But cats won't bark and dogs won't meow. So they just inherit the properties of the parent class animal, and then they make their own methods, meow and bark. Now, polymorphism provides a universal interface. Polymorphism translates to same operation, different behavior. So this is play button. This play button might also play an audio track, but in different page it might also play a video file, and in different place it might also launch a video game. So just one method is same name, but it's doing many tasks. So this is how you define polymorphism. Now, encapsulation just wraps up data and methods, all classes and methods, so it becomes one and it's safer. So abstraction, as I already told, suppose you want to drive a car, all the engines, the wiring, the fuel pumps, the motors, everything is hidden, and only thing that's shown to you is the car controls, and so ABC, accelerator, brake, and clutch, and steering wheel. So this is called abstraction. Abstraction means hiding up of the data which is not relevant to the user. The completed architectural structures, a car. Suppose this is a car. It comes under the vehicle superclass, or and the parent class, you can say. Abstraction, you can only drive the car, you don't have to just wire everything every time. So encapsulation, it binded all the engines, battery, steering wheel, everything in one so that it can work. So polymorphism is shown. The accelerate command behaves differently in eco mode versus sports mode. And inheritance, the EV class inherits the vehicle class, just like I said, a vehicle. Then you can say there are many other type of vehicle. This is inheritance. Now, software is a living, organized system. Object-oriented programming is more than just a syntax. It's just a philosophy of structural design. By mastering classes, objects, and other four pillars, you are no longer just rewriting lines of code. You are architecting system where a piece is defined identity, a protected state, and a purposeful behavior. So what it's stating is that object-oriented programming is not any syntax. Okay, it's just a way of writing code. So it's just a way of writing code to organize data that can be used in real life. That can be used in real life. That can be used in real life. So this is object-oriented programming. Now I'll just show you one example with this PPT. Um, See, suppose you want to build a model for a dog, all right? So there are many parts of building a dog. First of all, you will have to use a blueprint. See, it has everything, the dimensions, the class, the material it will be using, the how will the legs move, how will the head move, how will the ear move, how the tail move, how the bodies will move, how the previous hind legs will be moving, and this is the proper object, and this is a class. So the problem is scattered variables. Suppose this take this as C language, because it uses procedural programming. So there are many names, age, just like there will be many variables if there are many dogs. So if we use object-oriented behavior, there is a class dog, right? And there is dog one. Its name will be Buddy. Its age will be 3, and it will be barking. Now dog 2 will be same thing, and it's just in a not in a scattered manner like this, rather than it's just in structured order. Now understanding the fundamentals of distinction between uh, a concept and building it. So first of all, a class, as I already told, it's a blueprint for objects, right? Blueprint for objects. Now it defines attributes and methods. All right. It's created using class keyword, and definition of object is that it's instance of a class. It also uses it defines attributes and methods, but it uses attributes and methods. There is a difference. You can note it down. Now syntax is created by calling the class. Now drafting the master blueprint using the class keyword establishes a new type of object in Python. Now it's a shared attribute. Just I have told it in the earlier PPT. Calling the class brings a unique localized instance into existence. Now master blueprint is this, and there are two different dogs, and they are independent structures with independent object names. So this is how you. This is basically a default syntax for everything. You always have to define a method called init. This is called constructor, and you have to write self and the attributes you want to, the parameters you want to enter. Now, internal plumbing. The self is a reference to the current instance. It ensures that the program modifies its object's data, not overarching the data. This I'll be showing using a program. Now, class variable and instance variable. So class variable will only work inside a class, and it will be same for all the dogs. Okay. Suppose you want to enter a sound, it will bark. Now it will act like a radio signal, you can say, and this suppose this is a sound, it will be same for all the dogs because you have initialized it without a self keyword. But if you use self keyword, it will be used for itself only. It won't be used for any other object. So next is putting signage, the str translator. So this is, I guess, not in the syllabus. So what is the ultimate goal of object-oriented programming? So moving from procedural chaos to scalable, robust architecture and using real-life design. First of all, for optimization. Second of all, for easier understanding, code reusability, modularity. You can change and you can just shift code, and it won't cause any problems. And also integrity. If you used object-oriented programming approach, it will stay integrated. Just no all the values will be same everywhere in the every points. Now the basics of object-oriented programming are over. I'll just show programs for object-oriented programming now. I'm just waiting for the IDE to open. So I'll open folder. So now we'll be creating a class. I'll just zoom in for you. Let's say I make a class dog, and now I define and construct the constructor. Then use self. Let's say name, age, and breed. Now I will just say self dot name equals to name, self dot age equals to age, self dot breed. You can make take any name in this left side, because it's just you are defining it. So let's say we will use shortcuts, name, age, and breed. So breed. Now breed. Now let's say I create an object dog1. I use dog dog dot. I'll just initialize it in the beginning. Let's say name is Rodo, age is 2 years, and breed is, let's say, German Shepherd. Now dog1 has been created. Now let's say I create another entity, dog2. Now let's say make it Tommy 3, and I'll say Labrador Retriever. Now I'll make another method. Let's say info. I'll just write self here. Self has to be written everywhere where you are using the self keyword. I'll just say mm, I'll just say print, not here. Print the name of the dog is self dot name. I guess I erased it by mistake. No, no. Self dot name, and it is self dot a years old, while being a uh, self dot breed. Self dot breed. Now I'll just write printf is written already. Now let's say I'm calling this function. I'm calling in, say, dog one dot info and dog two dot info. So it gives info for the dog one and dog two. So this is how classes work. Now, if I give you example for a car, let's say class is vehicle, it's a car for now, and we'll just define initialize self, name, age, and brand. Same thing here. Now I'll write def drive and I'll write here self, and it will just print car of brand self dot p is now driving. Now I'll just say X clutch the clutch for car B is now pressed and the gear can now be changed. And now we can say accelerate mm, accelerator for car is now pressed and the car is now accelerating. Let's say CC here just for convenience purposes. Now you can have more than one classes in a single program. Yes, I'm just commenting it out for you know just visibility purposes, so that you can focus on just um, what we are studying right now. Now let's say I make a car one and say car, name of the car, let's say Leo, and age will be 4 years, and brand will be, let's say, Suzuki. And same way I can make many cars. Let's say X. Let's say over here. And here we can write Honda City, Suzuki Alto, and here we can write Hyundai Verna. Now what I can do is just say car one dot accelerate, and I can also say car one dot clutch, and I can also say car one dot drive. Now the accelerator for the car Suzuki Alto is now pressed and the car is now accelerating. Clutch for the Car Alto is now pressed and the gear can now be changed. The car of brand Suzuki Alto is now driving. So this is how you can use object-oriented programming in real life. Now I'll just say car 2 and car 3. Now every car's acceleration, clutch and driving will be shown here. So this is how we can use object-oriented programming in real life. I have demonstrated the coding for object-oriented programming too. Now, in the next lecture, we'll be studying about the four main pillars of object-oriented programming. That is inheritance, abstraction, polymorphism, and encapsulation. After that, we'll be diving into self-keyword, and after that, we'll do a few questions on it. And if time permits, we'll be also doing exception handling in Python. So that is it for today's lecture. Thank you.